To explain tokens, let's start by describing the alternative. Here we have a web application and a number of microservices. You could secure the communication between the browser and the web server or edge service, which will be exposed externally, and leave the internal services behind a firewall unsecured. To maintain state, you could include user info like the username in the body or query string of the requests. However, you're leaving yourself exposed to anyone who breaks into your network or anyone working in your organization. There have been a number of high-profile hacks that were perpetrated by insiders like contractors or consultants. You could pass the user credentials along with each request. A popular approach is via basic authentication. This is basically a base64 encoded string of the username:password, which is added to the header of the request with the authorization property, with basic space encoded string. This would be passed down with each request, and each endpoint would authenticate the username and password with perhaps an identity provider like LDAP. However, this approach doesn't scale. Each hop requires a call to the identity provider to authenticate the credentials and retrieve the identity details. And too many services are handling credentials, increasing the chance of them being leaked. To improve this, after authentication with credentials is performed with the identity provider, an identifier like a GUID is returned, which could then be sent instead. The identifier is a pointer to the state in the identity server. It can then be passed around to other services. The services can verify and source the identity details from the provider. This solves the password problem, as it's no longer handled by the services. This is essentially a token. You would send it in a similar manner as the basic authentication, just with the bearer prefix. However, in its current form, it's no different than a password. If the token gets leaked, it could be used to access anything just like the password. In fact, it might be worse than a password because the user cannot simply change it, and it doesn't solve the scaling problem due to the identity checks at each hop. This is why tokens also have an expiry time associated with them, to limit damage if exposed. Now, this type of token is referred to as a by reference token. It is a reference to the resource. Another type of token is a by value token, which will include the state information within it, like the username, email, and what the bearer of the token is authorized for, hence eliminating the need to call the identity provider. These tokens are generally signed by the provider, hence services can use the public keys of the provider to ensure it is valid and hasn't been tampered with. For most use cases, a by reference is fine, and the additional hops to the identity server has the benefit of allowing you to invalidate the identifier with the identity provider. By value is generally preferred as it saves you the hop to the identity provider. However, anyone with access to the token has the visibility of the contents, and in certain circumstances, you might not want that as the data could be sensitive or give insight to the types of roles, authorizations in your application. This can, however, be solved with encryption or the use of opaque tokens instead. The format of a by value token can be whatever you require. However, what should you use? The answer is a standard format, as you don't want to be in a situation where every application you're integrating with requires a different way of parsing, validating, and translating the token. So what standard formats are there? In the 90s, it was Kerberos. Early 2000s, SAML. And today it's JSON Web Token, pronounced as JWT. However, I always get it wrong and refer to it as JWT. Sometimes, by mistake, you might even catch me referring to it as Java Web Tokens. Now, JWTs are in JSON format, SAML in XML. This makes JWTs more lightweight, compact, and easier to parse, and hence mobile friendly. It is digitally signed to prevent it from being tampered with, and is base64 encoded, so you can put it anywhere, even in a URL, unlike SAML. It's also protocol agnostic. With SAML, you need to use a SAML server and protocol, whereas JWT doesn't mandate how you use it.